for this video, we're going to look at problem number 8 out of module 4. In this problem, you're given a right triangle where you have 2 of the 3 sides are given to you, and you're asked to use that information to find all 6 trigonometric functions. Okay, so we're given angle A, so you can see that up there in the top corner of the triangle. We're given the side that is touching it, so that means this is the adjacent side because it touches the angle. This is our hypotenuse, and this is our opposite side because it's opposite because it does not share one of the sides that makes that angle. Okay, so we can calculate what our opposite side is by using the Pythagorean theorem. So we can say let A equal the 2, so that's 2 squared plus, we don't know what our opposite is, so we'll just use the variable x squared. You can use anything. We could have used, well, we'll use b squared, I guess, since Pythagorean's theorem is a squared plus b squared equals c squared. And then our hypotenuse is always c because it's the longest side, and that is 7 squared. So that gives me 4 plus b squared equals 49. We'll minus 4 from both sides. That's going to give us b squared is equal to 45. Now, if we take the square root of both sides, we get that b is the square root of 45. So something I do want to share with you, a way that I find easiest to break those radicals down is if we have this here, let's start with our smallest prime number, 2. Does 2 go into there? No. Now we'll move on to 3. 3. Does 3 go into 45? Yes. 3 goes into 45 15 times. So now let's factor 15. 15 is 3 times 5. Now you can see our entire tree is made up of prime numbers. So for every 2, we can pull 1 to the outside. So that means that our b is really 3. And what's left is on the inside is that square root of 5, which we did not circle. Okay, so now I know that my opposite here is equal to 3 square roots of 5. So I've given you guys a table here to kind of help you get in the mindset of doing these trigonometric functions. Okay, so we have our sine is our opposite over hypotenuse, cosine is our adjacent over hypotenuse. If you think back to the announcement I made, you'll see that I built out a triangle, and it kind of helps you to visualize that SOHCAHTOA in remembering how to put these trigonometric functions together. Okay. So the first one, we have our opposite over our hypotenuse. Our opposite here is going to be our opposite is 3 square roots of 5, and our hypotenuse is 7. Okay. Then we have our cosine. Our cosine is going to be our adjacent, which is 2, over our hypotenuse, which is 7. Okay? Our tangent is that's the TOA, so that's our opposite over adjacent. So our opposite is 3 square roots of 5 over our adjacent, which is 2. Our cosecant, that is the reciprocal of sine. So you can either do the reciprocal of sine, or you can do the opposite or the hypotenuse over the opposite. So we'll do the reciprocal of sine is 7 over 3 square roots of 5. Now, the thing to take note here is you have to rationalize your denominator. In order to rationalize your denominator, we're going to multiply by the square root of 5 over the square root of 5. to get that radical out of our denominator. So that's going to give me 7 square roots of 5 over, this is 3 times 5, which is 15. Okay. And for our secant is the reciprocal of cosine. So that's going to be 7 over 2. And our cotangent is the reciprocal of our tangent. And so that is 2 over 3 square roots of 5. Again, we have to rationalize that denominator. So we'll multiply by that radical. And that gives us 2 square roots of 5 over 15.